Good evening, everyone. This is Unit 5 of IAL Physics, June 2050. The first question, light from distant galaxies analyze the line spectrum obtained is compared with a similar radiation from Sun. So when compared when compared the light from the Sun, the line spectrum of a light from distant galaxies, because as these galaxies, they are moving away from us, so the frequency which we receive will be lower frequency will decrease and the wavelength will increase. And what happened to energy of the photon? We have the formula E is equals to HF. The apparent frequency decrease, the energy will also decrease. So D is the right answer, lower frequency and a smaller photon energy. A Hertzsprung Russell diagram is a plot of luminosity against temperature for a range of stars. One group of HR diagram is a main sequence. Select a row of the table that describe the main sequence star. They have a low temperature, they have low luminosity, and they have low masses. That's why A is the right answer, which matches with all the characteristic of main sequence stars. Olympus Mons is the highest mountain on Mars. The height of Olympus Mons is 22 km, which is about 0.6% of the radius of the Mars. The change in the gravitational strength from bottom. So the formula which relate the gravitational strength with the distance, the size, G is equals to capital D, the gravitation constant M divided by R square. So this is 0.6% of R and this one is R. So at the bottom of this Olympus Mons, the gravitational field strength will be Gm R square. And at the top, the gravitational field strength will be Gm. This will be R plus 0.6% R and then whole square. So when we solve this, this will be Gm. When we convert the percentage into the decimal, so it will be 0.06. So it will be R plus 0.006 R and then whole square. And when we further solve, so it will be Gm. This will be 1.006 R square. So when we square this, so this will be Gm and 1.006 square, that is equals to 1.10, sorry, 1.012. So the value, the change in the, we need a difference. So if we need a difference, so basically the change in the value of the radius will decide the difference in the value of G. So when we take a difference of these two values, 1.012 R square minus R square, so the difference in the value is coming out as 0.12 R square. And in terms of percentage, what is the change in terms of percentage? This is 0.012 R square. So when we convert it to percentage, it will be 1.2% of R square. So what it shows the value, the change in the value for R will be 1.2%. So the change in value for the gravity will also be 1.2%, because due to variation in this R square, the change in the value is 1.2%. So the change in gravitational constant is also 1.2%, and as we know they are inverse squares. So if radius is inside, distance from the center is increasing, then the gravity should decrease. So if it is increasing, the R square, basically R square is changing by 1.2%, so this should decrease by 1.2%. So that's why B is the right answer. Which of the following is not a unit of electric field strength? So Newton, when we check Newton, ampere, so Newton, that is a force, ampere, that's current, then divided by distance. So we have the formula, V is equals to ED, or E is equals to F over Q, and Q is equals to, so Q is equals to current into time, the charge coulomb. So we don't have a unit in which ampere and meter inverse is there. So this is not the unit. Why B can be a unit? Because it is Newton. So force per unit charge. So force per unit charge is E, that's true. Newton per kilogram. So Newton per kilogram, that's value for G, because W is equals to mg. So G is equals to W divided by M. So Newton per kilogram, that's also true. And we have the formula V is equals to ED, so E is equals to V divided by T, D, so volts and meter inverse, so that's E, electric field strength. But this does not give any strength of the field. And if it was magnetic field strength, so F is equals to BIL, so B is equals to F divided by IL, so it will be Newton, ampere and distance, but not, it should be Newton, ampere inverse, distance or meter inverse. But it is not, so that's why A is not the right answer. For question 15, a mass hanging from the end of a vertical spring set into undamped simple harmonic motion of amplitude A. The total energy G. What is the amplitude of when the amplitude of oscillation is increased to A? What is the total energy? So we have half kx square. So if amplitude is double, it will vary with the square, so this will be multiplied by 4, so this will be 4c. Because if amplitude is A, like it is half Ka square. If amplitude is A, energy is E, but the amplitude is twice, so the energy will be 4 times the original value. Question 6, a student is using a Geiger counter to measure the number of counts per minute for a weak radioactive source. To determine the background rate, their best procedure is to measure the count for 1 minute before the source's position, 1 minute with the source position, 10 minutes before, like we can have an average count, so it should have 10 minutes before the source is placed, so we can identify the background counts. In early 20th century, Hubble determined the distance to range of nearby galaxy. Which of the following method would have allowed him to do this? What he did, he used Cepheid variable, and using those Cepheid variable, Hubble obtained enough observation and he plot a graph for its light curve and determine the period which indicate the Cepheid variable, and using the brightness of these Cepheid variable, he was able to calculate a distance for nearby galaxy. So B is the right answer. He collect the data and later he use and calculate V is equals to H naught into D, but he observed Cepheid variable and work out the distance between the galaxies or nearby galaxy. Question 8. In earthquake-proof building, the amplitude of vibration of a building is prevented for becoming too large by using a material which deforms. So if the material is deforming, it should deform plastically so it can absorb greater amount of energy. It should not be brittle. It cannot absorb energy. If it was stiff also, greater force is needed to produce a small deformation. If it is elastic deformation, it will absorb energy and it will re-radiate that energy. So that will not be effective. It should undergo a plastic deformation. So enormous or greater amount of energy being absorbed from the system from due to these earthquakes. Which graph shows how the pressure vary with volume for a fixed mass? So according to Boyle's law, pressure and volume are inversely proportional. Increase in pressure reduces the volume, so it follow inverse square law. So B is it follow inverse law only, that P is inversely proportional to V, not the inverse square. A sample of radioactive isotope decay to a stable isotope, which graph shows what happened to this sample. So basically what is happening, a sample of radioactive decay to stable isotope, which graph shows how number of daughter nuclei. So number of the daughter nuclei will increase, exponential change is there, so number of daughter nuclei, the stable nuclei should increase. So that's why D is the right answer. So this was June 2015 IAL Unit 5.